Merkle Tree in blockchain, what is it, how does it work, and its benefits. Hash tree, also known as Merkle tree, is a tree in which each leaf node is labeled with a cryptographic hash of a data block, and each non-leaf node is labeled with cryptographic hash of its child nodes labels. The majority of hash tree implementations are binary. Each node has two child nodes, but they can also have many more child nodes. But what actually is Merkle tree in blockchain, and how it used in blockchain? What is Merkle tree? Merkle trees, also known as binary hash trees, are a prevalent sort of data structure in computer science. In Bitcoin and other cryptocurrencies, they are used to encrypt blockchain data more efficiently and securely. It's a mathematical data structure made up of hashes of various data blocks that summarize all the transactions in a block. Also, it also enables quick and secure content verification across big data sets and verifies the consistency and content of the data. What is Merkle root? Merkle root is a simple mathematical method for confining the fact on a Merkle tree. They are used in cryptography to ensure that data blocks sent through a peer-to-peer network are whole, damaged, and unleashed. They play a very crucial role in computation required to keep cryptocurrencies like Bitcoin and other running. Cryptographic hash functions. Hash functions maps any type of arbitrary data of any length to a fixed size output. It is commonly used in cryptography since it is a cryptographic function. They are efficient and are well known for one property. They are irreversible. It is one function that only meant to work in one direction. Some of the hash families available to message direct MD, secure hash function SHF, and pair message direct. Now take an example. If you have HA256 hash algorithm, in conclusion there are following key properties of the hash function: deterministic, pre-image resistance, computerly efficient, cannot be reserved engineered, and others. Working of Merkle trees. Merkle tree totals a transaction in a block and generates a digital fingerprint of the entire set of operations, allowing the user to verify whether it includes a transaction in the block. Merkle trees are made by hashing pairs of nodes repeatedly until only one hash remains. This hash is known as a Merkle root or the root hash. They are built from the bottom using transaction IDs, which are hashes of individual transactions. Each non-leaf node is a hash of its previous hash, and every leaf node is a hash of transactional data. Now look a little example of Merkle tree in blockchain to help you understand the concept. Consider the following scenario: A, B, C, and D are 4 transactions, all included on the same block. Each transaction is then hashed, leaving you with hash A, hash B, hash D, hash C, and hash D. The hashes are paired together, result in hash AB and hash CD, and therefore your Merkle root is formed by combining these two hashes, hash IBCD. In reality, a Merkle tree is much more complicated, especially when each transaction ID is 64 characters long. Still, this example helps you have a good overview of how the algorithms work and why they are so effective. Benefits of Merkle tree in blockchain. Merkle trees provide four significant advantages. First of them is validate the data integrity. It can be used to validate the data integrity effectively. Takes little disk space compared to other data structures. The Merkle tree takes up very little disk space. Tiny information across network. Merkle tree can be broken down into small pieces for verification. Efficient verification. The data format is efficient, and verifying the data's integrity takes only a few moments. Why is it essential to blockchain? Think of a blockchain without Merkle trees to get a sense of how vital they are for blockchain technology. Let's have one of the Bitcoin because its use of Merkle tree is essential for the cryptocurrency and easier to grasp. If Bitcoin didn't include Merkle tree per se, every node on network would have to retain a complete copy of every single Bitcoin transaction ever made. One can imagine how much information that would be. Any authentication request on Bitcoin would require an enormous amount of data to be transferred over the network. Therefore, you will need to validate the data on your own. To confirm that there were no modifications, a computer used for validation would need a lot of computing power to compare ledgers. Merkle tree a solution to this issue. They hash records in counting and separating the proof of data from data itself. Use cases of Merkle tree in blockchain. There are more Merkle tree implementations out there. Git, it's a distributed version control system, is one of the most widely used. It is used to handle projects by programmers from all around the world. Also, it's part of technical that guarantees variable certificate transparency logs. Amazon, DynamoDB, and Apache use it during the data replication process. This non-SQL distributed databases use Merkle trees to control discrepancies.